Okay, so hello guys. Today we will get start a new lesson and basically is about graphing and is graphing linear and exponential equations. It's not like too hard, but yeah, let's get started here. Okay. So we have four parts. Like basically two parts. One of them is linear graphing, and another one is quadratic graph. And then we have like some practice problem that I prepared to you guys. Okay, well, but let's rotate today. So each person gonna like do one slide. So let's start from Bonnie. So Bernie is the first one, and then Ifan can go second, and then Nicholas, and then you three are gonna rotate. Cause yeah, and then get started. You can.
So this is a linear function. So a linear function is a function that is composed of straight lines, and for a linear function, you need at least 2 points to plot a straight line, like to form a solid linear line. And the general representations of a linear function are through three equations: y equals to kx plus b, y minus h equals to k times x minus a, and ax plus by plus c equals to 0. So um, in in the three equations, um, in the first equation, k is the slope of the line, which is the y over x, and b is the y-intercept of the line. And for the second equation, h um, is the y-intercept of the line, and k is K is K is the dilation of the line, and A is the left and right shift of the line. And in AX plus BY plus C form, um, you can expand the first two equations to arrive at this equation. And you can convert them however you like, and it all depends on which equation you like the most.
So the ways to draw a linear function. Theme one, you're given that y equal kx plus b. And so the way you graph it is, for example, you're given y equal 0.75 x plus 3 and interpret it, which k equal at y increases k as x increase 1, and for b is where you start on y-axis. So y increase 0.75 as x increase in 1 in this case. So y increases 3 as x increases 4. Oh my god, do I have to read all this? Progress the number according to the axis and connect the starting point to the ending point, and you're done with it. For theme two, you are given that x1, x2, y2, and x2, y2. So for example, is 2, 1, and 5, 6. So you just graph 2 point and connect it. And for theme three, you're given y minus h equal k parentheses x minus a. And for example, is y minus 5 equal to parentheses x minus 5. So the equation indicates a point AH, which recognize the slope k is y increase, k as x increase 1, and then you just plug the point in.
Okay, so for sorry Nicholas, but for practice question we can just choose some of them to to
Okay, do you want me to? Okay, I can choose then.
Yeah.
So let's practice graphing the first number one on the left. How? Oh yeah, I guess we'll just give you a minute to do that. All right. Should I show how to do it, or like, is there a way? How should I show?
Uh, can you annotate on the screen?
Oh, I can. Okay.
Yeah. Mhm.
So for number one, your graph should look something like, sorry, this is a bit bad, but it should look something like this. Where this point, the y-intercept, oops, this point is 0, 7, and the x-intercept is 7/4, 0. It's a 7. All right. So next we can do, let's try number 4 on the left. I'll also give you a little bit to do that. All right, so I'm going to draw it out. Sorry, the dog is barking. All right, so the, all right, this is good. Sorry about that. So the number 4 should look something like this. I'll label the 2 key points. One is the x-intercept, which is 7, 0, and the y-intercept, which is 0, -7. All right. Next one we can do is, let's try g, y equals 1/4 x plus 1. Give you a minute. All right. So now I will show the graph for G. You should have something that looks like that. The slope is smaller, so it should, the graph should look a bit flatter. But some important points are here, which is 0, comma 1, and back here, which is -4, -4, comma 0. All right, and we can do one more. Let's try W. So this one has an absolute value sign, which means that the 2x part, you will always take the positive part of it, meaning if 2x is -1 or something like that, the absolute value makes it equal to 1 instead of -1. So try to plot out a couple of points, like plug in x equals 0, x equals 1, x equals -1, x equals -2, and see if you can draw the graph for W. All right, so this one is a bit trickier. So I will show more points that you can graph. So one that I would start with is when x equals 0. So when x equals 0, y equals 0 plus 2 or 2. So that means 1 point is at 0, comma 2 right there. If you try x equals 1, you get 2 times 1 is 2. The positive version of that is still 2. So then 2 plus 2 is 4. So then at x equals 1, you'll have 2 comma 4. X equals 2, you'll have y equals 6. So that keeps going up there like that. And so you see on the positive x side, you'll have a line going up like that. Now when x becomes negative, you'll see something interesting. So when you plug in x equals -1, you get -1 times 2 is -2, but then the absolute value of that is +2. So +2 plus 2 is 4. So you'll actually get -1 comma 4. If you do the same thing for x equals -2, you will get +6. So you can see when you keep drawing like that, it's actually symmetrical. So that is what W, the graph of W looks like. All right, so that was some quick practice. Let's keep going.
So now moving on to quadratic functions. Quadratic functions are not linear anymore, so they're not straight and they curve at a point called the axis of symmetry, as you can see in the lower left diagram. And there's two forms of quadratic functions, vertex form and non-vertex form. So vertex form is written as y equals to a times x minus h squared plus k, and any other form that is not vertex form is just non-vertex form. So in vertex form, the vertex is k, which is the minimum or maximum point of the quadratic function, and in the diagram, the vertex is the lowest point, which is where the quadratic function curves. And it tells us, the vertex form also tells us whether the graph opens up or down if we see A is negative or positive.
Eva?
So graphing quadratic functions. Quadratic in vertex form is start by plotting the vertex hk and determine if the graph opens up or down. So if it's negative at the front, negative a, so it's up and down. And if it's positive, it's open up. So the last step is to find another point by plugging an x, and you can use that point to finish the graph.
All right, quadratics in non-vertex form. First, you have to find the zeros of the function and plot those points. To find the vertex, you can find the average of the two x-intercepts, or you can use x equals negative b over 2a because the graph is symmetrical. We can use the x we just found and plug it into the original equation to find the y and then graph that point.
So here are a few practice questions, and you can choose like 3 or 4 to do them. Okay, so I'll do like 3 questions with you guys. So we can do number A. So for A, um, we can see that at 0, 0 to the power of 2 is remains 0. So we know that there's a point at um, the origin 0, 0. And then this is also the vertex of the quadratic function. And then if we choose 2, so if we choose 2, 2 to the power of 2 is 4, so it would be somewhere around here. And then negative 2 to the power of 2, since it's in brackets to the power of 2, it will also be a positive number, so it will also be 4. And if we choose, let's say 3, 3 to the power of 2 is 9. And from what we did on the left side, negative 3 to the power of 2 is also 9. So it's here. And if we just connect the points, we form a quadratic function that passes through 0, 0, and it goes, opens upwards. Another one we could do is E. So for E, yeah, so for E, if we choose the point 0, it goes, it's also at 0, 0. And then if we choose 1, if we choose 1, it ends up at -2, so it's around here. And then if we choose -1, it is at 3. So we kind of see a trend that it's going like negatively to the right. So if we choose point -2, so -2 to the square root of 2 is, -2 to the power of 2 is 4, and then -2 times 2 is also 4. It's also 4, so then it should be 8, so it should be even higher. And then if we choose 3, -3 to the power of 2 is 9, and then -2 times 3 is 6, so that's 15. And if we just continue going like this, we should be able to if we, let me just double check. I'm sorry. Yeah, and if we just plot out the points, we see that this side to the left goes all the way up, and if we continue on the right, we will see that there's a point that curves back up. So in the end, the quadratic function should be like that. And another question can be h. So for h, we can see that it is -x squared. So since there's a negative sign, we know that this point opens downwards. And there's also a -1, which means that the graph shifts downwards by 1 unit. And so this graph would look like, we know that the vertex of the graph would be at 0, -1. And then if we just choose points on the left and the right of the y axis, we can see that. So for example, for 2, it would be -4 minus 1, which would be -5. And for -2, it would be also -4 minus 1, which is -5. And we can see that the quadratic opens downwards like this.
Okay. So I think this is the last slides for today. And then, yeah, hope you guys understand, well, not everything, but most of them. And then, yeah, I think we can end here today. Janet, I think you can stop